Experts say that at the rate we're going, water shortages will become more and more commonplace. Many cities around the world may even run out of usable water by the year 2040. Despite the fact that water covers roughly 71% of the Earth's surface, only about 3% of it is drinkable, and it's often not where it needs to be. That's why some believe desalination is the way forward, and if the technology behind it becomes affordable and accessible, settlements around the world will be able to avoid their dreaded day zero, which is the term used by scientists to refer to the date when a population's water supply runs out. There are several different desalination technologies in use today, each with its own set of benefits and drawbacks. The oldest and simplest way to desalinate water is through thermal distillation. About 35% of desalination plants in the world use this technique. In thermal distillation, seawater is filtered to remove larger impurities before being heated to produce vapor. Any salts in the water are collected and separated, after which the remaining vapor is condensed back into pure mineral-free water. A more popular method of desalination is through the process of reverse osmosis, which is used by about 60% of desalination plants worldwide. Reverse osmosis filters out salt and other impurities in salt water using an extremely fine semi-permeable membrane with pores measuring 1/1000th of a millimeter. This extremely fine filtering is crucial as it traps salt molecules behind it and only allows water molecules to pass through. The result is pure water. Keep in mind that the pure water produced from these processes is not yet safe for human consumption. It must first be ionized with trace amounts of minerals such as calcium, potassium, and magnesium. Otherwise, it can actually kill you. Pure water disturbs the balance of electrolytes in your body, causing your cells to absorb massive amounts of water and ravaging your central nervous system. You may be wondering what happens to all the salt that is left over from the desalination process. Unfortunately, these methods cannot purify all of the water used. The rest of it turns into brine, which is water that has been supersaturated with salt and desalination chemicals, such as chlorine and copper. Due to this byproduct, experts question the sustainability of our current desalination methods, as this brine is pumped back into the sea. The introduction of this hyper-salted water causes significant damage to the coastal ecologies near desalination plants, and it can only get worse in the long run. It should also be noted that constructing these plants is currently very expensive. Only about 300 million people, or less than 4% of the world's population, rely on desalination plants for their water supply. Saudi Arabia and the US make up a huge chunk of this figure, and Kuwait is currently the only country that relies on desalination for the majority of its water supply. However, with global warming and the resulting droughts ravaging many parts of the world, the development of desalination facilities is becoming increasingly urgent. Experts estimate that the water produced through desalination will double in the coming decade. Even with these drawbacks in mind, the future looks promising due to a recent development in water treatment technology, the zero liquid discharge water treatment. This is thanks to a new method of processing brine, temperature swing solvent extraction, or TSSE for short. By mixing a low polarity solvent with brine and bringing the solution to about 41 degrees Fahrenheit, the solvent is able to extract the water from the mixture, leaving behind the salts as ions. Scientists can eventually separate the water and salt completely by controlling the solvent-to-brine ratio. After this, the temperature of the solution is raised to about 158 degrees Fahrenheit, and the solvent is separated from the water. TSSE is also far more energy efficient than traditional desalination methods. Due to its forgiving temperature requirements, the thermal energy needed to power this process can be sourced more sustainably. Rethinking potential energy sources for the process is one way scientists are working to make desalination more accessible. Scientists hope to reduce the overall energy cost of desalination by using waste heat as an energy source for small-scale thermally driven desalination processes. This would in turn make it feasible for remote communities to have access to this technology. Another benefit of using waste heat as an energy source is the potential for increased energy efficiency in communities that rely on diesel power. Around 40 to 50% of a diesel engine's energy output is low-grade heat expelled from the engine through an exhaust, which is the same type of low-grade heat that scientists have used to power small-scale desalination operations. With significant advances in water filtration over the last 20 years, it's only a matter of time before desalination becomes much more common. In the meantime, we should conserve the water we do have and do our part in holding off day zero in our communities.